Hi, and welcome to this edition of Excel for Introductory Statistics. In this video, I want to talk about the coefficient of variation. Now, we've talked about the standard deviation, both in class and in a previous video. Now, the standard deviation is a metric which we use to sort of quantify the amount of variation within a set. Now, if we want to start comparing two or more sets to each other, and ask questions like, which set contains more variation? Well, we can't use the standard deviation. For that, we use what is called the coefficient of variation, and that's what we're going to calculate here. This is going to be a relatively short video because there's not much to it. Now, one, there's no built-in Excel function for the coefficient of variation. And that's because the formula is very it's very succinct. It's very simple, meaning there's not too many components to it. It's just one number divided by another number. Specifically, the standard deviation divided by the mean. Now, if we look at these two sets of data on the left-hand side, I have one highlighted green. That's the weight of 20 randomly selected pugs. This is a type of dog with a really squished up face. Now you look at that set and you say, okay, well, all of those numbers, now it's an ordered array, so they're in order from smallest to largest. All of those numbers are within about 10 pounds of each other, from 11.9 at the smallest, or the minimum, to 21.9 as the maximum. So they span about 10 units, 10 pounds. And then on the right, in orange, we have the weights of 20 randomly selected black rhinos. Now they span a whole lot more than 10 pounds. The smallest is 2,689 pounds. The largest is 3,291 pounds. So they span about 600 pounds. All right, so the range of set A is 10, and the range of set B is about 600. So you may say, okay, well, set B is more spread out than set A, so set B contains more variation. Now, it might, I don't know yet, but that's not a sufficient method for comparing the variation within two sets. For that, we need the coefficient of variation. Now, there's a sample version and a population version, and both calculations are the same. We take the standard deviation and divide it by the mean. And we could convert that, and that'll give us a decimal, and we could convert that to a percentage if we want. In this case, the directions say convert it to a percentage rounded to 3 decimal places. So we need two things. We need the standard deviation. So on Excel, that's equal stdev.s for sample standard deviation, and then in parentheses, location of the data. And then we have to divide that by the mean. And our Excel function for mean is equal average, parentheses, location of the data. So if you already know how to calculate the mean and the standard deviation, which we've covered in previous videos, calculating the coefficient of variation is very easy because you just do the standard deviation and the mean, and then you divide those two numbers. So let's calculate the coefficient of variation for the weights of 20 randomly selected pugs. I'll do that here in column E. Okay, so we'll calculate the mean first. So that's equal average, parentheses, and our data is in locations A2 up through A21. So we have a mean or an average weight of 16.7 pounds. And now the standard deviation equal stdev.s, and same location, A2 to A21. Now that we have these two values for the coefficient of variation, we could divide them. So I'll say equal, and I'll just click on the locations, equal the standard deviation, which is in location E3, and divide that by the mean, which is in E2. And since we want a percentage, the directions aren't always going to say give it as a percentage, but in this case, we want a percentage run to the 3 decimal places. So let's use the drop-down menu, convert it to a percentage, and we'll give it 1 more decimal place. So 19.145% is the coefficient of variation. Now, coefficient of variation for set B, which is the weights of 20 randomly selected black rhinos. So let's calculate the mean. So equal average, parentheses, location, B2 to B21. Now we've got our standard deviation equal STDEV.S, parenthesis. Again, that's the sample standard deviation. Okay. And for the coefficient of variation, that's CV, coefficient of variation, let's divide, so equal the standard deviation divided by the mean. And again, let's convert that to a percentage, and we'll round that to 3 decimal places. So now the coefficient of variation is used to compare 2 or more sets to each other and answer the question, which set has more variation? And in this example, based on these results, it looks like set A, or the weights of the 20 randomly selected pugs, has more variation. So set A has more variation, even though the range of set A was only 10, while the range of set B was about 600. And the standard deviation of set A was 3.2, and the standard deviation of set B was 154.8. But when we calculate the coefficient of variation, we see that set A has more inherent variability relative to the values within its own set. All right, that does it for this video. I hope this was helpful.